quickly, let us look at this now. Chemical properties of metal. Now, to study chemical properties of metal, we want to talk about how metal reacts with water, how metal reacts with water, how metal reacts with oxygen, and how metal reacts with acid. So, to discuss about these chemical properties of metal, chemical properties of metal. Now, you must know the reactivity series. So, we want to look at how metal reacts with water, okay? How metal reacts with oxygen, and how metal reacts with acid. Now, reactivity series, I will help you to memorize it with this recitation. So, this recitation will help you to memorize the reactivity series. What is reactivity series? Reactivity series is a series of metal arranged from most reactive to least reactive. All right, but if I'm too fast, you can pause the video or play the video to get what I have said. So, reactivity series of metal is a series that contains metal arranged according to reactivity. That is starting from most reactive metal to least reactive metal, and you are supposed to memorize that. So this acronym will help you to memorize that. Please stop calling Mark A. Zuckerberg in London. Okay, all right. Please Paul, Mr. Social guy. Each word here represents a metal. All right, represent a metal. Like this represent potassium, which is positive ion. While stop represents sodium. All right. Calling, that is calcium. Okay. Mark, that is magnesium. Aluminium, that is this is a Zuckerberg represent aluminium, Al. All right. Zuckerberg, Zn. In, that is iron. All right. Iron is Fe plus or Fe3 plus. London, okay. London is, that's lead, Pb 2 plus. That is hydrogen. Now you'll be wondering, why is hydrogen included in this series? Hydrogen is not a metal, but it is included in this series as a reference point. Hydrogen stands as a reference point. Okay, I will tell you why. Now, Paul, that is copper. Mr., that is silver. Mercury, actually, that's mercury. Social, as silver. Silver is Ag plus. Then guy, that is gold. Now, there's another way you can memorize this reactivity series. I posted that on the team channel. Okay, now quickly let's go to team channel. Let me quickly show you something that I have sent. I sent these notes, this meta notes. Let me download it for you to see. This meta notes. Let me download for you to see. So while that is downloading, okay, all right. Hold on. So you can also use this to memorize reactivity series of metal. Where is that now? All right. Let me download this as well. Okay. Now look at this. Please stop calling me a careless zebra. Instead, try learning how copper saves gold. You can also use this to memorize the reactivity series of metal. All right. Now let's look at our notes. We are trying to look at the chemical properties of metal now. Let's look at our notes. All right. All right. It's trying to open right now. Just a minute. Okay. Just a minute. Okay. Just a minute. Then we are still on chemical properties of metal. It should open now. Okay, now under chemical properties of metal, look at it now. Please stop calling Mark. It is arranged like that according to reactivity. Now, when we talk about reaction with water, reaction with acid. Now we are using this as an acid, hydrochloric acid. We are using hydrochloric acid, for example. Trying to write on this hydrochloric acid, for example. Now, reaction with water. Metal do not react with water the same way. Now, the most reactive metal are the first three metal actually. Now, this one they react with cold water very violently. Now, potassium is even explosively and is dangerous. Potassium and sodium, they are dangerous. When they react with water, they explode. All right, so that experiment is not advisable to be carried out. While calcium can react with water vigorously but not explosively, magnesium reacts with water. Magnesium reacts with water very slowly. All right, now see, zinc and iron react only with steam. Magnesium reacts with water very slowly. Now zinc and iron does not react with cold water. The water has to be in a hot form, that is steam form, before reaction can take place. All right. So now hydrogen is our reference. Any metal below hydrogen cannot react with water in any way, whether in cold form or in steam form. So please take note of that chemical behavior of water, chemical behavior of metal. Now reaction with acid. Now all these metal will react with acid except metal below hydrogen. Metal below hydrogen do not react with dilute acid except if the acid is concentrated. But all metal above hydrogen, they react with acid, either explosively or moderately and so on. Now reaction with oxygen. Anytime metal reacts with oxygen, reduction of oxide, or anytime metal reacts with oxygen, it forms metal oxide. So it's very important you can represent with this with an equation. equation. Now, metal below hydrogen. Okay, now let's go back to our board here. Please take note of this. You know, I told you that this one react violently with water, explosively with water, while this one react violently with water, and then this one react slowly with cold water. And then aluminium, zinc, iron, and lead react with hot water, only with hot water. If the water is hot, before reaction can take place. And then copper, mercury, zinc, and copper, mercury, silver, and gold does not even react with water at all. So these are chemical properties of water. All right. Now, there's something that is very important for you to note when it comes to extraction of metal. The first 5 metals, that is potassium, sodium, calcium, magnesium, aluminium. The first 5 metals, when you want to extract them, you extract them by electrolysis. Why do we extract them by electrolysis? This is because they are very reactive. You don't see them in ordinary states. You see them in combined state. Take for example, if you are going to see aluminium, you see aluminium as aluminium oxide. You can never see aluminium alone because aluminium is very reactive. So it's always in combined states. And if you must separate aluminium from oxygen, because the force of attraction between aluminium and oxygen is very strong, you have to pass through electrolysis. That's the only way you can separate aluminium from oxygen. So take note of that. And then every other metal before hydrogen, starting from aluminium, please stop calling mark Zuckerberg, zinc, iron in London, and then lead. All right. We can now extract this one by what is called reaction with carbon. Reaction with carbon. So we call this reaction reduction reaction. Reduction reaction. Now this we will learn it more tomorrow. So we are talking about properties, chemical properties of metal. I hope you've gotten something. You can replay the chemical properties of metal and get more understanding. Now we are going to uses of metal now. Use of metal now. Now when we talk about use of metal, we use metal based on their property. Take for example, we can't use aluminium as our food flask. Why? Because we can't use iron, as our food flask. Why? Because iron gets rust. It gets rusted easily. All right. So if you use iron as your food flask, it can get rusted, and the particle will contaminate your food, and that can cause health issue. So rather, we use aluminium. Aluminium does not get rusted easily. So I want to show you a slide now. I'm just trying to pick this slide now. Hold on. Okay. Right, just hold on. Okay, now look at this. So aluminium, what we use aluminium for? Based on the properties of aluminium, it has a low density. Aluminium has a low density. Trying to write here now. Aluminium has a low density. If you can see my picture, it has a low density and does not corrode easily. Now, the fact that it does not corrode easily make aluminium very stable for food flasks or for cooking utensils. Now, because it has a low density, that makes aluminium very useful for overhead cable that we need to be very light, because it's very heavy, it can drop and cause serious accident. And the body of aircraft needs to be very, very light so that the aircraft can lift up and float in the air. So we use aluminium, we don't use heavy metal. All right. Now, why do we use gold? What are the properties of gold that make it very useful for its use? Because gold does not react. Very, very unreactive metal, and that's why gold is used for jewelry. So you can wear your jewelry in the sun, in the rain, and it will not corrode. Copper is very, very good for electrical conductor because of its ductility. It can be drawn into different sides of wire. That's copper. And the iron, though it can get rust easily, but it is used in building because of its strength. It's very strong, especially when you mix iron with carbon. You get a very strong metal. And then titanium also is very, very strong, and it is very resistant to corrosion. So used for in the making of some devices, like our watchmaking, some devices, knife, and so on and so forth. So you can see use of metal depends on the property of metal. That's the key point I want you to take away. Now let's look at our objective again. Let's see which one we are yet to cover, because I intend to make the lesson very, 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 very short. Alright, just hold on. Okay, I'm trying to get to my slide now. Okay, sorry. Now we look at the meaning of metal. We look at the meaning of metal. We look at properties of metal, which are uses of metal. Now we look at chemical. That's the activity series somehow. We look at the activity series where we talk about electrolysis, extraction by electrolysis, and reaction of extraction by electrolysis and reaction with carbon. That's called reduction reaction. Where I mentioned, please stop calling mark Zuckerberg and London. So we'll talk about the activity series. Now let's talk about alloy. Alloy is the mixing of two or more metals together. Okay, better put, Alloy is when you mix two or more substance with a metal. Now, if I say mixing of two or more metals together is an alloy, sometimes we mix carbon with iron, and carbon is not a metal. So it is safe to say this. Let me show you. It is safe to say this. The meaning of an alloy now. Alloy is the mixing of a substance. The substance can be a metal or another metal. It's a metal. That's an alloy. Now, why do we mix substance with a metal? Number one, to improve its appearance. Number two, to increase its quality. Number three, to prevent corrosion. So this is the reason why we do alloy. Some people do alloy not for this reason, but to cheat. So when you decide to cheat your customer, your customer demand for gold necklace, but what you have is copper necklace, and then you now mix small gold with it. So that is not the purpose of alloy. So that's cheating. So these three statements are the reason why we do alloy. So imagine you want your metal to have good quality. You can decide to mix it with the proper alloy. Now let me give you an example of an alloy now. Take for example, if you have heard about the metal steel before. Steel is a mixture of carbon and iron to give you steel. Though we have different kinds of steel. We have stainless steel. Now, stainless steel is a mixture of carbon plus iron plus nickel and then plus chromium. Now, we use stainless steel in our homes for cutlery, your knife, your spoon, your fork, your cutlery. So I think we need to stop right here. I hope the video is not too long. So tomorrow we'll talk about extraction of metal. Most probably we'll be looking at extraction of iron, and extraction of aluminium tomorrow. So for now, have a nice day. I hope you have gained something. So you can always rewind, pause to understand for better understanding. Thank you very, very, very much.